topic is probability-dependent events. And if I asked you what the word dependent means, anybody? Basically, what differentiates dependent from independent is if something's dependent, it depends on the outcome of the first one. It's the opposite of what we call independent. Okay, independent means they're completely by themselves. Okay, independent depends on the first. And here's an example. Let's just say, how many 7th graders are there?
18.
There are, how many boys?
10.
10 boys and 8 girls. That's not right, yeah, in 7th grade. What is the probability of randomly picking 2 boys? In other words, if I took all your names, made little slips of paper, put them in a hat, and pulled them out, what would be the probability of picking 2 boys? Okay, now that probability, by the way, I would do it like this, probability of boy, comma, boy. Now the reason this is called a dependent event is because the probability of the second thing happening changes with the first thing happening. In other words, this. What is the probability of picking the first boy? Well, there are 10 out of 18 boys, or 10 out of 18 are boys, right? So the probability of me just picking one boy is 10 over 18, which is whatever it is, 5/9. Okay, but the probability of picking the second one has now changed, because if you pull the boy out, there's no longer still 10 boys' names in there, nor are there still 18 people in there. So that actually changes for the second one. There's only 9 boys left, and there's only 17 slips of paper left. So that's why this is a dependent event, because the first one depends on the other. Now, if I said I was going to draw the boy's name and then put the name back in and start from scratch again, no, then it becomes independent. But since I said, you're pulling one and then trying to get 2 different boys' names, it's going to be dependent. So if we actually reduce this down, it doesn't work too bad. So this is 5 over 9, and the 9's cross off. You have a 5 in 17 chance of randomly drawing 2 boys' names out of the thing there. If I asked you the probability of rolling a 6 and then a 3 on a dice, is that independent or dependent? It's independent, because whatever you roll the first time, it has no bearing on what happens when you roll the second time. So this would be just, there's 1 out of 6 chance here times 1 out of 6 chance there. 1 in 36 times you're going to roll a 6 and then a 3. Okay. Usually when we talk about dependent events, it's when we're pulling marbles and stuff out of a bag or something. So here's our bag. Let's do what is the probability? Let's say I've got 1, 2, 3, 1, 2, 3, and 1, 2, 3, 4. If I asked you the probability of picking 2 blues, and then they'll say without replacement. If it says without replacement, that means it's going to be dependent. That would be this. The probability of picking the first blue is what? 4 out of 10, right? And the probability of picking the second blue, though, if you don't put that blue marble back in there, you've only got 3 blue marbles left and only 9 total marbles altogether. So you multiply those together, you do some cross-canceling, 1/3 and 2/5. 2/15 is your probability of picking 2 blue marbles right off the proverbial bat. I don't know if they ask me anything more than that. Look at page 560, please.